In this tutorial, I have provided in detail the Spring Security architecture and the Spring Security component, as well how Spring Security works. And here in the part 1, we will talk on the Spring Web MVC architecture and the Spring Security authentication architecture. And then in the part 2 of this, we will create new Spring Security Hello World project, and then in the part 3 we will see how we will manage the user using Spring Security user class. We will define a user with the default in-memory user details manager provided by the Spring Security. We will also learn creating custom user class to define user credential, setting password, username, and authority based on user details interface. And we will also learn how creating custom in-memory user details service class with implementation of user details service, user management configuration using custom user details and user details service. And then we will also learn about the password encoder, delegating password encoder, plain text implementation of the password encoder interface. In the part 6, we will learn how authentication provider works, as well implementing custom authentication logic. We also have part 7, we will configure authorization, which is securing endpoints. And in this part 8 of this, we will learn how authentication filter works, creating custom authentication filter, adding custom filter in the chain. And this will be the last part of this tutorial. So let's go and start. Here is the architecture of the Spring MVC. Client make request to the server, and then the request is received here by the dispatcher servlet, and then based on the URL, the dispatcher find the associated action. And then after finding the associated action, what is the associated action in this case is home. So we have home URL, and then here is the home, which represent a method, which is a method, and then view resolver, which is we have here home.html. After the action is executed, the view is found and render as response. This arrow that we have here represent the request and response from the client. So request from the client and the response from the dispatcher servlet. Okay, so the next thing we will look at is the architecture of the Spring Security authentication. So here is the architecture of the Spring Security authentication. At first, we have a client request, and then here is the step 1 that we have. So in this step 1, we have authentication filter. The request that have produced by the client, which is the request made by the client, is intercepted by the authentication filter. So then after authentication filter intercepted the request, then it will send it to the authentication manager, which is the number 2 that we have here. The authentication responsibility is given to authentication manager. Then after receiving this, then the authentication manager uses authentication provider, which implement the authentication logic. So this is the authentication provider here in number 3. Authentication provider implements the authentication logic. So we have an interface which is called authentication provider, and this interface have define the contract which will be implemented by the custom authentication provider. So in this case, authentication provider uses user detail services and the password encoder. User detail service is we will load the username. Based on the username, it will load the user and his credential, and then the password encoder will validate the password. So here is the arrow which represent the request and the response. If the authentication is success, then it will store in the security context. The authentication details are stored in security context after this process, and if the process is not success, then it will return to login page, which is the login page. Okay, here is the architecture of the Spring Security, and the next thing we will look at authentication and authorization. Authentication and authorization. Phase authentication is who are you. So when you come to log into the application, that is the authentication. It will use the password and the username to authenticate you. But after the authentication, the next thing is that authorization. There are certain things that you are not allowed to do. There are certain things that you are allowed to do. For example, if you have a bank application, so if you try to access the bank application, the authorization here is that you can only transfer money from your account. So you cannot transfer from someone's account. This is the authorization. So here I have a user with the name Aliyu, and then after the authentication he get access to the application. So and then after the access to the getting access to the application, here we have localhost 8080 Aliyu, which represent the URL. So the authorization here will give his authority only on this URL. He will not access the data and information which is not his own. So this is the simple example on how it works. Let's create a new project for our Spring Security tutorial here in the Spring Starter project. So here I already have the name available, the name of the project Spring Security tutorial. The group is coding techniques as well as the package. So we are using Maven here. Java version is 11. So now let's click next to add the dependency. So I need Spring Web, Spring Security, and then Spring Boot DevTool for live reload. So let's click finish. The import is getting started. So here is our project, and in this coding techniques package we have our starter class. Let's open it. We have the starter class. So you see we have the starter class here. The next thing is to run application. So let's click run as Spring Boot app. Now the application will run, and we will check if our dependency is in place. So here is the application running. So now we have this generated password, which is called universally unique identifier. Okay, this is what we will use as password, and the user is user. The username is user. So let me go back to this architecture. Spring Security provide interface for all these components. The interface have the implementation which provide by the Spring Security. you know, the interface is a set of contract, and these contract have their implementation for the Spring Security. That's why if we run the application, we have this generated password, and if we use this password and the username, it will authenticate us. So this is to make the development easier. We don't need to create all this from the scratch, so we just need to override this to match the need of our application. Okay, now we will learn how to override all these components and the right way to override them to match the need of our application. So now let's try to use this to for the authentication. We copy the password, and now each endpoint that accesses this, despite that we don't have any endpoint, it will take us to the login page. Okay, so this is the work of the authentication filter. We will not access any part now unless we are authenticated. So the request is intercepted by this authentication filter, and this we have authentication manager. This authentication provider provide whether the authentication is success or not. So, and it will use user detail service and password encoder. Okay, now let's go back to the browser. You can copy this and go back to the browser. The username in this case is user, and then we paste the password. For now that we doesn't have any endpoint, we will have a white label error page. So now we will create a controller class with the endpoint hello. So now let's create a package for the controller. So now we will create a class, new class. Let's have it as user controller. Okay, so here is the class. You see that the application is reloading itself because we are using Spring Dev tool. You see another password generated. So now the old password that we use will not work. So this is a new password. As we run the application and save the program, or the live reload save the program, we will have a new password. So, and the old password is expired. Now let's annotate this class with address controller. So this address controller consists of both controller and the response body. So I will use get mapping here, and then have this part hello, and as well as the method that we will use here is public string hello. Now we want to return hello world. Okay, now if we save the project, we will have a new auto-generated password. Okay, now let's copy and access it. So before we access, we have to log out the current session. How we will do this is we have the URL logout like this, and if you click and logout, we will have new, we will have been signed out. Okay, so now let's access the hello part again. You see the request is intercepted, and if we sign correctly, you see we have hello world. So before having the configuration class and override some of the implementation, and I will show you how to change this password in the application.properties. Now let's go to the application.properties. So using this spring.security security.user and .name, we will define the username, or we will add new username, and here I add the username Aliyu, and then we will also change the password spring.security.user.password in this case. So, and let me add this as password. Now take a look. If we save the project, now we will not have this auto generated password. Okay, now here is what we have with no auto generated password because we use this. And let's access this. Now we have to log out this session. Now log out. So we will use the username we provide Aliyu and the password. Okay, now we accesses this part. Okay, that is the because we did not attempt to access the hello page at the face. But if you log out again and then try to access the hello part, then we have the password and the 1 2 3 4. So here is a hello part. Okay, so this is what we have so far, and this also will not be used for the production ready application. So I will show you step by step how to override some of these components. The next thing we will do is we will override this user detail service and password encoder. So let's do this together. Now let's delete this to have a package for our configuration. Let's create a package called config. So in this package we will create a new class, security config. So here is the class. First thing we will do is to annotate this class with add configuration. Then let's go back to our diagram that we have here. So what we will focus here is we will focus on the user detail service and the password encoder. The password encoder used to validate the password, and the user detail service load the user from the data source. So in this case we will create two bins of user detail service and password encoder, and let's create bin, and this the bin that we will create now will override the one that we have default by the Spring Security. So public user detail service, I will start with the user detail service, and this is the interface, and this interface is used to load the user, and it uses the implementation of the user details to return the user credential. Okay, for now let's create the method, and we will use the in-memory user details manager. We have in-memory user details manager, and let's name the variable as user details service. Okay, so equal to new, and we will repeat this again to create the object of the in-memory user details manager. So this is what we have. So this name is too long. Let's just have the keyword var here, so nothing changes. It will not change the implementation. So, and we will return the user details service. This is the variable. So the in-memory user details manager implement the user details service. That's why we are using it here. So in the next chapters we will create our own implementation of the user details service, but now we will be using the in-memory user details manager. So the next thing we will do is to create the user and link it to the user in-memory user details manager that we will have. To create a user, we will use the user class of the Spring Security, and we will use user details interface. So for now, let's use the user details interface as just a type. So the type is user details, and here we have the variable, and here we will create a user. So we will be using the user from this package, security core user details. So now we will access the members of these static members. In the static members we have username. Okay, with username, now we will add the username. We have Aliyu. You will have the username of your own as well. So password, let me add the password as 1234, and then if we want we will also add the authority. So here is the authority, and let me say have right here as the authority, and the next thing is the call a method build. So now we created this user. Okay, so now how we will link the user to our user in-memory user details manager? We will just use the variable user details service, then have create. We have the method create user, and then we will pass this user here. So we have the user pass here. So this is the user details service that we have, the bin of user details service. What remaining is that we will have the bin of the password encoder as well. So to have the bin of the password encoder, we will have to have add bin again. We'll annotate it. This will override the default one that we have with the Spring Security. So now let's create the password encoder. Why we need the password encoder is that it have to validate this. So here we have the password encoder as a plain text. The password encoder is an interface, and it have implementations. The implementation include the bycrypt, which is if we have the password hash as a bycrypt, then we will have to use the bycrypt. In this case we have the password as plain text, so we will use plain text implementation of the plain text. So you will see the implementation of the plain text that provided by the Spring Security in a second. So now we need a password encoder, then now let's return this implementation. So the name of the class that have the implementation of the plain text is called no password encoder. Here is the class. So this class have no, we will not create the constructor like we used to do it. We will get the instance of the class by calling get instance. So this is how we call the class. And note that this class is deprecated. Okay, you see we have this class as deprecated because it is not because of the version, it is because this will not be used for production ready application. It is not secured to use a plain text of implementation for the production ready application. So now, since that this method is deprecated, let's add the surprise warning. Okay, so we have admin. So this is the two that we have now, and this password encoder implementation will validate this as a plain text. So in the next part we also have the password encoder. We will discuss it in detail, but for now let's focus on this configuration. Okay, so we have now 2 bin, and this 2 bin will override the default that we have. But before running the application, first let's have also a bin of security filter term that is for the request authorizations. So let's have public filter term. We have securities. It starts with security filter term. So here is the method security filter term, security filter term. So the name of the method, and this method will have the parameter of HTTP security, HTTP security. And let's have the variable HTTP. So, and what we will do here is to use the HTTP variable to access the members of these. So the first member that I want to access is we have HTTP basic, HTTP basic. So this is the implementation of that authorization that focus on only password and the username. So, and then we will call HTTP. We have the method. First let's close this and have authorize. Call this method authorize request. So we have the one that have the lambda expiration, and we have the one that has no lambda expiration. I will use the one with the lambda expiration. Okay, now this method is used to authorize the request, permit some requests, and authenticate some requests, have different implementation of the request. We will discuss this in the last part of this tutorial. So for now, let's use authorize as the variable of the lambda equal to authorize. Then this is the lambda expiration, so we will access this any request, that is, we'll call any request that we have and then authenticated. So any request that we try to access by using this, any request that we try to access will be authenticated, and we are having error because this will throw an exception. Let add throws to the method declaration. So, and then we will return http dot build. So this is what we have, and any request that we have will be authenticated if we try to access any request. And remember, we have hello request in our controller. So now let me run this application so I'll see if we have the implementation correctly. Now the application is running. So now you see, having this implementation, we have this generated password. So now let's try to access. So let's try to access this. Hello, hello, hello. So you see how the HTTP basic is, which is different from what we are using before. So this is how it look like the form. So let's add Aliyu and then add 1 2 3 4 as the password. Try to access. So now we access this hello part. Okay, this is what we have here. So now what we will do next is we are going to the next chapter, in which we will have our implementation. So the implementation we will have include having the user class of our own, which will implement these user details, and we will implement this in memory. We will implement this user detail service interface. Again, we will have our custom in-memory user details manager. So this is what we will do. We will look at this user management in detail. So let's do this together. In this part, we will focus on creating our own custom in-memory user details manager. This one that we use, as I said earlier, is provided by the Spring Security. This class is the implementation of user detail service, and now we will create our own implementation of the user detail service. So we will also create the user, which is custom user. This user is provided by the Spring Security from this package, Spring Framework Security Core User Detail Service. We will create our own, and then we will change this implementation after creating our own. So now to create our own custom user, we will start. Let's create a package, new package, then let's name this package model. Inside this package, we will create a new class. The class is user. Okay, so here is our class. This class is not an entity class. We will not store this in the database. We will just implement the user details. So let's implement the user details. Let's implement the user details. Okay, so this is different from the user detail service. User detail service used to load the user by username, and this user details contract provides us a way to define a user credential. Now let's implement the method that we have in this class, in this interface, user details, add on implemented method. So here is the contract, and it provides us a way to define user, his password, the authority, and we will specify if we want the account to expire or not. We will also specify if we want the account to be locked or not. So in this case, we don't want the account to be locked or expired or disabled. So these are the 4 implementation that we will just return through. Our focus will be only on the username, password, and the authority. Okay, now let's return through for this. So let's return through, and we will return through for the order is account not locked. Let's return true. We don't want the account to lock. So now remaining these 3 implementation. Okay, to have this we will create a field. We will have 3 private field. First one is the string username. Okay, we will have username, and the second one is private string password. Okay, we will have the password, and the last one we will have private string authority. Okay, so we will start with the implementing this granted authority, in which we will return a list of authority. So let's use this of and then pass lambda. Okay, and then return the authority. Okay, this is what we will return with this method. And the other method, get password, we will just return the password that we define. So, and then the last one, which is get username, we will also return the username. So by implementing this contract, Spring Security will understand our definition of the user. So now we have to provide a constructor using this field, so that we will pass our username, password, and authority from the security config class. Okay, now let's go to sources, generate constructor using field. Okay, then this is what we have. Okay, so this is the implementation of our user class using the user details. And then the next thing, we will create a custom in-memory user details manager. Okay, so now let's create another package. Let's create a package dot service. Okay, so here is a package, and inside this package let's create a class, and let's name it custom in memory user details manager. Custom in memory user details manager. Okay, here is our class, custom in memory user details manager, and this class will implement the user details service. We will use this to load the user from the data source. Okay, we have a single method here, and this is the method load username, and the type of the method is user details. Okay, so now let's create a data source that we will load the user. So the data source will be just a list. In this case, we are not using the database. In case if you will be using database, you will use the find by username method and then fetch the user by his username. Okay, now I will show you how to do it using the list. Okay, now let's have a list, and the list will be of type user details. Okay, and then have users like this. So now we created this list, we have to create a constructor, generate constructor using field. Here is our field. Let's generate a constructor. So now we generate a constructor. Now I will use these users to fetch the data. Okay, now let's remove this generated comment and then use our field that we created, a list, and then we will use stream. Okay, we use stream. Okay, so here we will use the filter, and then we will filter the user that has the user which his username is equal to this as in the parameter. So let's use the lambda user list as a lambda variable. So inside this user list we will get the username of a user. Okay, get username, and then after getting username we will check if the username is equals to the one provided here. Okay, so now let me break this line to have the view clear and widen the screen as well. Okay, so and if we find the first user that have this, we will use this method find first. Okay, the first user that is equals, that his username is equals to this, we will find the user using this. Okay, so and the last thing we will do is to, if we did not find the user, so if we did not find the user, we will use this or else to throw an exception, and the type of exception will be new username not found exception, and we will pass a message. Okay, we will pass a message, and the message will be user not found. Okay, so we use stream pipe and filtered the user which his username is equals to the username here, and then we find the user. If we did not find the user with the username, then we throw an exception. Okay, so we also need another method, as in the security config. This in-memory user details manager has the method create user, so as well we will create user also. We will have this method create user. So let's check, let's go back to the custom in-memory user details manager and then have this password public. It will be of type user details service. Okay, and then let's name it create user, and in the parameter we will pass the list of users. Let's pass the list of users and then return the object costume, return costume in memory user details manager. We will have here new costume in memory user details manager and pass the users that we have here as parameter. Okay, so we have this method, and then we also have the method load user. So this is the implementation that we will have. We will pass the list of users to this method, and this method will pass it to the constructor of this class. So after having our list in the constructor of this class, and this method load user will use the list to fetch the data, and in case of the fetching the data of the user from the database, we will fetch it using the JPA custom method find by username. So for now we finish with this implementation. Let's save it, and let's save this one as well. Okay, so now we will go back to our security config. Let's go back to the security config and change the implementation of this. We will use our own now. Let's change this. So let me remove this as well. Okay, now we will use the user details as a type, and then we will use the new user. The user we created from the model package. Here is the user, string, username, password, string authority. So we are having this specified by the name of the package because we already have this user import, okay, from the user details, which is the previous one provided by the Spring Security. That is why we have this prefix to identify them in case if we have the user, if we define the other user in this method. Okay, so now let's pass the username as Aliyu, and then I will pass the password as 1234, and then I will also pass the authority as read. Okay, so and we will create a list to add this user, list of type user details, and then call the name of the list users equal to, we will use the list of, okay, list of, let's add the user. For now we have a single user. Okay, then this method will return, let's go back to the custom in-memory user details manager and set this to static so that we can access it without creating an object. So here we will use custom in-memory user details manager, then create user. Okay, then we pass these users to this, and it will use it as a data source in the custom in-memory user details manager. So this is the implementation we have so far. Let's rerun the application and check if our implementation is working correctly. So the application started. Okay, now let's check if we have this working correctly. Localhost, let's try to access the hello path. Okay, for now we have to close the browser and open it again because we already have the authenticated user. Let's use localhost hello. Okay, now we have this. Let's try to add the user that we just 1 2 3 4 and then try accessing. Okay, now you see we access this successful. Okay, so now let's try like 2 more users or 1 user. Let me duplicate this and give this as user 1 and the other one as user 2, and let me change this to Usman, and then let's reduce the password to just 123. Okay, now I will pass user 1 and then I will also pass user 2. So let's save this and then try to access with the name that we provide, Usman. Okay, so now let me close the browser again and then open. So hello, using the hello. Okay, let me use Usman. Now Usman, and the name is 123. Let's try to access. Okay, so we access it successfully. No matter how the number of users we have, we will access successfully. Now the next thing what we will do in the next part, we will focus on the user, on the password encoder. So let's go to the next part. Okay, now in this part we will focus on the password encoder. Okay, so here in the couple of parts that we did earlier, we focus on this part 5 and the which is user management and using the user details service and user details interface. Then in this part we will focus on this password encoder. As I discussed earlier, the authentication provider uses user details service to load the user, and the user details service use the user details interface as well. And in case of the password encoder, in authentication provider use the password encoder to validate the password of the user. Okay, now we will focus on this password encoder. To focus on this, I want the all implementation that we have, and let me have the all implementation that provided by the Spring Security. Okay, so this is our all implementation, and since that we finish with this model class, we don't need it. Let's delete this, and we also don't need this custom in memory user details manager, and I will also delete this. So now we will focus on the password encoder. Okay, so now as I said earlier, we have this implementation for the plain text, but not in all the case we store the password in the plain text. So we have different implementation. We have by crypt password encoder. All this implementation is these classes implement this password encoder interface. So let me show you. After this no password encoder, we also have by crypt password encoder. Okay, we have by crypt password encoder, and to call it we have new by crypt password encoder. So this is, you see, this is not deprecated, and if we try to access using this password encoder, it will not access, and it will show you the password not look like by crypt. So let me run the application to show you as an example. So we have a plain text and we are using the by crypt password encoder. So this will not work, and let me rerun the application and try to access. So you will see the message that we will have in the terminal. Let me close the browser, and then we have this. Let's try to access the local host 8080. We have hello. Okay, let's try to access with the Aliyu 1234, the password. So you see it will not access, and in this we have in the console we have by crypt password encoder, and then it is written that it is written that encoded password does not look like bcrypt. Okay, this is because we have plain text, but in many implementation to that we have to do is we have to store this in the bcrypt. Okay, how we can store this in bcrypt? So let me show you how we store this in the bcrypt. So first we will encode the password. Let's have string here, and then set encoded password. Let's encode the password, encoded password. Okay, and then equal to, so let's create bcrypt password encoder, and let's just name the variable be we don't want it to be long, bcrypt password encoder. We will have new here, new bcrypt password encoder. Okay, then we will set that b, and we will access this encode. So in this case we have our password here, encode. So this password now is encoded password, so we have encoded this to bcrypt. So in this case we will pass the encoded password. So now if we try to access, we will access without having a problem. So now let's close the browser again. We are closing the browser because we have no implementation for logout so far. Now let's access the hello part. Okay, so here we have username and the password 1 2 3 4. So we accesses this because we encoded password. Okay, so this is not the only implementation of the password. Let me go back to the all implementation. Okay, so this is not the only class that implements password encoder. We also have script password encoder. We have script, script password encoder. So you see this, we have a couple of parameter here. We have 1 2 3 4 5. Okay, this first parameter that we have, it is called CPU cost, and then the value usually passed here is 16 then 384. So and this parameter that we have here, it is also called memory cost. It's called memory cost, and the value that is usually passed here is 8. We also have the third parameter, which is called parallelization coefficient. The value that we pass here is usually 1, and we also have the fourth parameter, which is we call key length, which is 32, and we also have salt length, which is 64. Okay, this is how the script password encoder works, and we will have our secret password encoder, and we will encode it like this, like we encoded this. And if we have tried to access this with the plain text, it will show us that the secret, this does not look like the secret password encoder. Okay, this is not the only implementation that we have. We also have another implementation of the password encoder interface, which is called PB. We have PBKD F2 password encoder. Okay, this is also the implementation of the, let me access the one with that has no, okay, here is the PBKDF password encoder. This also implement the password encoder interface. Okay, for now let's return our no password encoder, no password encoder. We don't need this new no password encoder.get instance. Okay, the implementation for the plain text. Okay, so now let's have this in the comment. Now we don't have a bin, so what we will do now is to create a custom plain text password encoder as this. So to do this is easy. We will just go to the service class and then have a class that implement password encoder interface. Let's call this plain text password encoder. Okay, plain text password encoder, and this will implement, let's implement the password encoder interface, and we have a two method here, which is encode, which we will use to encode the password, and the matrix, which is used to check if these two are equal. So now since that we will not use any hash algorithm to hash the password, let's return the raw password to string. We are just returning the password as it comes, so without any hashing. So, and in this case we will return the raw password that equals to the encoded password. So now let's save and then have this with add component so that it will be scanned. Okay, so if this is scanned, then we don't need the bin here. So even without this bin we don't have problem. Okay, let's try to access using the current implementation that we have. Okay, so let's close this again and try to access now to see if our implementation for the plain text password encoder works. Okay, localhost, hello, and then we have 1 2 3 4. So we have this, so our implementation works. Okay, now here is the implementation of the class. Okay, the implementation of the password encoder. Okay, now I will delete this and focus on the security config password encoder that we have. Now let's remove this comment. So even with this comment again, we also have what is called delegating password encoder. So in the delegating password encoder here, as you see, we have no, so we will prefix this with no. So Supreme Security will delegate this to the password password encoder without having the bin. So by just prefixing this with no, it will delegate the work to the password encoder. And what if we prefix this with by crypt like this? So it will delegate the work of this to the by crypt. So it already know the password that we will follow here is by crypt, so it will just delegate the work with the by crypt. As well as secret, if we have secret, it will delegate the work of the to the script without having this pin. Okay, now let's check if this works on the plain text password encoder. Nope. Okay, so we have nope here, and then now we doesn't have bin, and then we also deleted this our plain text password encoder. Okay, now let's rerun the application and then check if this provided nope works. Let me close the browser and open it again. So we have localhost, and let's access the hello path. Okay, username and EU, and the password 1234. So we access this successfully. Okay, because we have this no, and is the password that we have here is by crypt, we will just have it as by crypt. So now the question is that how delegating password encoder works. Password encoder works. Okay, to know how delegating password encoder works, I will show you the example of how delegating password encoder works. Okay, now if we have a bin, let's remove this comment and then let's delete this. Okay, in the case of delegating password encoder, we will have a bin of type of many password encoders. So, and we will put it in a map. Okay, so now we have a map of key and value. So the key here will be string, and the value will be password encoder string, and the value will be password encoder. Okay, so here we have encoder. We will name these as encoders because it is not only, we will add different. Okay, then equal to new hash map. New hash map. So now we will use this encoders variable to put the values. Okay, here the value will be, let me add no, and then we have we delegate this to the no or password encoder dot get instance, and the next we have encoders dot put. In this case we pass a by crypt. So by crypt, and we delegate this to the by crypt password encoder. New MVC crypt password encoder. Okay, so and we also have, let's have just 3. Okay, if we have these, then we have script. So, and we delegate this to the new script password encoder. Script password encoder, and then pass the value that we have passed, 16384, and then we pass this 8 1 32 64. Okay, so and then we will return, what we will return is we will return new delegating password encoder. Return new delegating password encoder. Okay, here we pass encoders, and then in the we will pass the default like noob or script, it doesn't matter. Okay, so this is how delegating password encoder. If we added this noob, it delegate the work to the no-op password encoder, which is plain text. If we are having this, if we have this as a script password encoder here, it will delegate the work to the script password encoder. Okay, this is what we have as a password encoder part. So the next part we will focus on the authentication provider, how it works, and then how we will implement the custom authentication provider. In this part we will focus on the authentication provider. As we discussed earlier, we said the authentication provider uses user details to load the user and the password encoder to validate the password. The authentication manager uses the authentication provider, which implement the authentication logic. Now we will implement our own authentication logic. So let's go back to our this will return the no op password encoder. We don't need this now. Okay, so let's use the no op password encoder .get instance. Okay, so to have our own authentication logic, let's create a new packets and name the package service. Here in the service we will create a custom authentication provider class. Custom authentication provider. So here is our custom authentication provider class. We will now implement the authentication provider interface and override the default authentication provider which provided by the Spring Security. Now let's implement the interface authentication provider. By implementing the authentication provider, now this program will use our own custom authentication provider, and let's annotate this with @service. So in this case we have two methods. The first method we will have our authentication logic, and the second method check whether the object that we use supports the type of the authentication we are using. So in many cases we are using username and password, and there are times when we will not use username and password. This class decide the support of the object. Okay, now let's start the implementation. As we said earlier, we use the password encoder and user detail service, so we need to have the user detail service and password encoder private user detail service, and then we need the password encoder private password encoder. Okay, we will use this and you will see how we will use this. Okay, now let's have the username that and the password that is trying to authenticate. String username, and then we use this authentication dot get name. This get name will get the username, and then we use string again to also get the password. Okay, so now we use authentication dot get credential. So using the get credential, we will get the password and then set it to string. Okay, this is what we have so far, and then the next thing we will do is to use the user details interface to have our user, to load the user. So we use this, but in this case we are now using this variable of the user detail service to load the user. So let's use user detail service and then load the user. So we will pass this username, so it will find the user by this username. Okay, now what we will do is to have the authentication logic using the if statement. So in this case we have two ways to do. Now let's do the first one. The first one, we will use the password encoder and then uses the matches method and check if this password that we have is equal to the password that we will get. User.get, we will use this user variable to get the password. So this password from the we have this password from the authentication.get credential, and we accesses the password that is loaded by the user detail service. So we have this, and the next thing, if this matches, then we will return what we will return here, that we will return new username password authentication token. Okay, new username password authentication token. Okay, here is the new username password authentication token, and we will pass the username and the password. Okay, now let's pass the username, and here we pass the password. So we have something to pass again here, but let me show you something. Here in the security config, we have this right, which is authority, and in case if you have authority and you have to pass it to the custom authentication provider, you will use the arrays, and then call the method as list. So, and then you pass the authorities and other credentials that you want to use for the authentication, but in this case we are not passing anything. So this is what we have, and then we will have the else. If it doesn't have the, then we will throw, then there is bad credential class, and we will throw new bad credential exception. Okay, let's use this throw, then new bad credential exception, and then we will have the message authentication error. So this is what we have, and for the support method we will return the class that we use, which is username password authentication. Okay, now let's return username password authentication. Okay, so now we will set that authentication dot equals, we'll use this equals what. So the class that we use, username password authentication token dot class. Okay, this implementation is okay, and there are cases when we will also return the just username password authentication dot class, and we will use this dot is assignable, and then we will pass this authentication as variable. Okay, both the method you use is okay as long as the object is username and password authentication token. Okay, so now we will check our implementation. So now let's check the implementation. Let's rerun the program and see if our authentication that we implement is working. So here is the program started. Okay, so now let's try to access the hello part that we have. Okay, we have this name Aliyu, and then we also have 1 2 3 4. So we are having error accessing. Let's check what is the problem. So let's check the password that we have. Okay, in this case we added this no after we already have the password encoder, so we don't need to do this. So let's try to access again. One, two, three, four. Okay, so now our implementation is working. So there are times when we will check both with the username and the password. Let's go back to the authentication provider. So there is time here we are only checking with the password. So let me delete this if statement and have another one. First we call the username and check if it is equals to the user dot get username. Again we will get the username here. So in the first we are checking the username first and then at, and so and then we will check the password dot equals the user dot get password. Again user dot get password. Okay, this is what we have. Let's save this implementation. So we don't need to inject this to authentication manager because we annotate this and it will be automatically scanned. So now let's close this and open again. So here we have let access localhost, hello, and then we have Aliyu, and then 1 2 3 4. So it is working again. But here is some advice here on here in the authentication if we forget to add the and we just added O, so even if the password is not correct, then it will pass. So, and this is not the right way to do this. Let me access this with the O. So even if I have not put the password correctly, it will pass, but as long as one of the either password or username is correct. So now let's use this and then access this part. Okay, let's have the username correct and the password is not correct. As we know, our password is 1234. Now let's just add one and see if it will pass. It passes because in the condition we have the just O, either one of the is correct, so you will always avoid using O. Okay, so this is our implementation of the authentication provider, and the next thing we will do is that we will look at the authorization. We will look how we will secure the part of our application. So in this part we will focus on the securing endpoint. Now we don't need this custom authentication provider, we will use the default one, but if you want you can keep the code, but for me now I will delete these and use the default. So, and you will notice that here we are using the HTTP basic. Now if we try to access like this localhost, any part that we try to access, it is authenticated. And why? Because here we set any request authenticated. Okay, so now first let me change this to form login, and you will see that it changes. So now let me use form login. Okay, so and then save this. Okay, so as you see, this is deprecated, and if you want you will just use the one with the lambda expiration form login, and then use form like this, and then the lambda, and then call get class. So this is also okay. So now let's save the project and then go to try to access this again. You see it changes to form login. This is the difference between the HTTP basic and the form login. So now whenever we try to access any part here, we will have this authentication. But now if we have any request, permit all, we have permit all. So this means that we permit all the requests that we have, we will access them without authentication. So now if we try to, let's save it first. So if we try to access the hello, we will access this with no authentication. Okay, so now let's go back, and we also have another method called deny all. So it will deny all access to every part. Now if we try to access hello, it will not access, even we have the username and the password correctly, it will not access the part Ali1234. So we will not have access to this because we have deny all. So and then we also have a method that we will add. Now we will add another method here, which is request matcher, the one that have the string. So here we will pass the method, we will pass the part that we want to. In this case we have this hello. Let me drop this down so that you will see it clearly. Here we have authorize, and we set this request to let authenticate this request. Okay, and any request, we will use any request after this hello. Let permit the request dot permit all. Okay, in this case it will have this request authenticated, and any request after this it will permit the request. Now let's go to the security user controller, and then let's duplicate this method, and let's have this like hi. So just an example. So with the implementation we have, let me change this to hi, like this. So with this implementation we will have the, let's go back to the security config. With this implementation, this hello is authenticated, but any request after this hello is not authenticated. Now let's try to access the hi. So you see we have access to hi, but we will not have access to hello. Now this hello is authenticated. So, and we will also use the request matcher. Instead of using this method, we will also use the request matcher again. While this is authenticated, we also need the request matcher again to set the hi. Okay, we set the hi like this, and then set this to permit all. So in this case we are permitting this request hello, and we authenticate this request, and we are permitting the hi request. All is the same implementation. So now let's have some get mapping to show more example. Okay, in this case let's change this to a, and let's have a like this, and then we will also duplicate this to change ab like this. We have ab, and then let's have up to c, a b c, abc, the name of the method, and then let's have another method get mapping using the a b c d like this. Okay, these are the get mapping that we provide with the first hello, and here we have the part as a/b, this one up to c, and this one up to d. So now let's go back to the security config. In this case, if we use to, let's remove this. Okay, in this case if we use something like this a/b, and then have something like this. Okay, if we have this star, means there are number of parts. The number of parts that we will have in this, all it will be authenticated. This will not only apply to the a and b. If it has this prefix, so whatever it will have in the front, so it will be authenticated. Now let's try this and see. First we will try with the a/b. so this part is authenticated, and even a/b/c, this one also authenticated. So the same with the same thing with a/b/c/d, and this will also be authenticated. And thing we will do is to add some role to this and try the hash role method. Okay, now let's try to add another user, and name is the first one user 1 and user 2, and have this like Usman. Okay, and then we will use this user 1, and then let's create another user for the user 2. So we have user 1 here, and we also have user 2, but let's give them different authority. Okay, now we set this authority to read. Okay, let's save the authority. So the next thing we will do is to have in the controller we will have. So for now, let me get rid of this, the remaining one. Let me have the part as user, and let me have this as admin. Okay, so, and go back to the security config. So here request matched with the user has authority. We have a method has authority, and the authority is, we will set this to read. Let's have read. And then the next thing, we will have a request matcher as well here for this part, admin, and set that it has the authority right. Okay, so here we set this to the authority read user, and here we have the authority to admin. So in this case, let's check who is the admin here with the right authority. The admin is Aliyu, and now let's try to access the part of the admin using this username Usman. Okay, now let's have the admin. Let's try to access the admin. Okay, now if we provide the Usman and his password, he will not access the path to admin. You see, access denied. Okay, now we test with the Usman try to access admin and it doesn't work. So now let's close the browser and then try to access with the name Aliyu, who is the admin. Okay, now if we try to access with Aliyu, we will have access to this. First, let's try admin. Okay, now and then use Aliyu 1 2 3 4. Okay, so now we accesses this part because he is the admin. So this is about the admin and the user. In this part of the series, we will look how we can implement filter. Here we have the client request, and we have said that in the explanation earlier, the request is intercepted by the authentication filter. Okay, now we will create our own authentication filter, so we will have to implement the filter interface. So now, before implementing filter, you have to know how this filter works. So here in the comment, let me explain. So we have a request like this. Let's say that we have a request, and let this represent the path that the request will follow. So we will have filter in this chain. Let's set filter A, and then followed by, let's set we have filter B, and then let's set that we also have filter C. So the request have to follow through these filters. So let's set that the first filter is the cross-site request forgery, which is cross-site request forgery, CSRF. And the second filter, let's set that it is cross-site request sharing, or cross-origin request sharing, cross-origin request sharing, CORS. And then let's say that here we have order, just order filter. So the requests have to follow through these filters. And to add the filter, so we will have the method, to add the filter before, and we also have the method to add the filter after, and we also have the method to add the filter on another filter. So you can access the method like this: http dot, we have add filter at, which is at the position of another filter. We also have add filter after, which is after another filter or before another filter. Here is the three method, but in this case we will add the filter before. So this is how it works. Now we have to create a package and implement filter. Our filter that we will create in this tutorial will be OTP filter. Okay, so now we are having error in this, so let's remove this that I created. Okay, so now we will have a new OTP filter. Let's create a package service. Inside this, let's create new class. Okay, this class, let it be OTP filter. So our class is loading. Here is our class OTP filter, and we will implement filter from Jakarta servlet. So this is the filter that we will implement, and it have only one method. So this contract provide us the way we will implement, or the way we will add our own logic. So, and you see that we have request, servlet request for request, and servlet response for the response, and then we have the filter chain, which we will pass it to the another filter. Okay, so now let's have the implementation of this. So we will use the call URL. Call URL is a tool used for request, sending URL request and response, to have response in the terminal. So we will use call URL to check our implementation and create a header. So but before then, let's create a HTTP servlet request. The difference between servlet request and HTTP servlet request is that this is specific to HTTP and this is more generic one. It may apply to the maybe file transfer. If you have a file transfer, you will this class implement the servlet request. If you have to use file for the request, then you will use this servlet request and implement some of the logic that we have inside this servlet request to your FTP. So in this case, we are using the HTTP for our request, so we will use HTTP servlet request. Let's have HTTP request, okay, and then set it to the request of this parameter. Here we will have an error or because we have the different type. So now let's cast this to the servlet request. Okay, so let's cast it manually. Okay, so we are having this error. Let's add cast to HTTP servlet request. So we are casting this request to HTTP server, and we need a response, HTTP response, and let's name the method HTTP response. HTTP response equal to this, and we will map this to HTTP response. So we will map this response to HTTP response. Okay, so now let's create our OTP, a string that we will store our OTP, and let's set that to OTP. Then we will use the HTTP request to get the header, and we will create the header later in the call URL. So here let's set the header to OTP. So, and the last thing we will do now is to check if our OTP is equal to a unique OTP. We will create some unique OTP or a single unique OTP. So we will set that OTP that equals, let's set our unique OTP is 1236. so this will be unique. We will check if the OTP provided during the request at the header, if it is equal to this, we will have access to the request. So now if this happens, it equals to the 1236. Now we will call the chain variable and call do and pass the request and the response. So we are passing the request to another filter. And what happens if we have an error? It does not provide the same as this one. So if we have not provided something the same as this, then we will throw HTTP response.set status and then HTTP response dot sc unauthorized. We will have the unauthorized. Okay, this is what we will have. So now we finish with the implementation of our filter, the next thing we will do is to add the filter in the security config. Adding the filter in the security config, here is where we will add the filter to the http.add before. We will add the filter before, and adding the filter before, now we will call our new OTP filter. So here is our new OTP filter, and the next parameter we will pass the basic authentication filter dot class. Okay, this is our basic authentication filter dot class, and let's close this. So now we add our filter in the chain, our custom filter for the OTP. So now let's save this and then try to access it in the terminal. So to access this in the terminal, we use call and then followed by h, then we create our OTP header. To create OTP header, here is how we create OTP header, and then set the value. We set the value to 1236, and then the next thing we will do is to call our URL. Now let's go back to copy this http hello. We will try to access this http hello. So here we will try to access, we create OTP. Now if it is success, we will have hello world printed here. So if it is not success, it will not show what we have. Okay, let's go back to the terminal here. So it shows that it is not success because we are having error. So let's check our class. Let's rerun the project again to check where we are having this error. Okay, we are having this error because in the OTP filter we did not annotate this with add component. We will annotate this with add component. Okay, then save the project, go back to the terminal. In the terminal, let's try to, so our application room, let's try to start with the call again using -h and add the OTP. So the OTP is 1236 unique value. So let's paste our URL here and recheck again. So let's go back to the terminal. Here we have hello, and if we set this value of the OTP to, let's add different value OTP, let's set 123. Okay, and then paste. We will not have this message. Okay, now let's try now and see. So you see we haven't have this message, but if we use the correct OTP we provided, so let's copy this. Okay, no, not this one. Let paste this here. We will have the hello world provided here. So that is because in our OTP we set the value if it is equal to the 1236, it will pass this chain. So this is the last component we will talk in this tutorial, we will discuss about in this tutorial. And maybe you are interested in the custom registration and login with admin. I have this in my channel, Coding Techniques, and you will subscribe for more videos on programming and other frameworks as well.